Okay, so again, assume the floor is smooth. And the surface between the blocks is rough, and it has a coefficient of static friction, like the two materials have a coefficient of static friction of, let's say, 0.5 between them. Okay. A's mass, let's assume, is 2 kg. B's mass, let us assume, is some, okay, 3 kg. And we pull the lower block. Let's say with a force of 5 Newton. Now see, we know that if we pull the lower block gently, they'll slide together. And if we pull the lower block with too much of a force, lower block will slide faster than the upper block. They'll slip over each other. Okay, that we could like we saw that also, but we don't know if this 5 Newton is a weak force or strong enough to separate them. Okay, so now we'll have to do the calculation. So yeah, system was at rest initially. We start pulling the lower block with a force of 5 Newton. You have to find out what happens. So the question is to calculate the accelerations of the blocks and also the amount of friction acting between them. Think of an approach. How to do this? Any ideas?
I think we calculate the friction acting on the block like B, like because the force 5 Newton is acting on B, we'll calculate the friction acting on that, and then we'll do F net is equal, acceleration is equal to F net by M.
Okay. How to calculate friction acting on the block B?
0.5 into 5N.
Why will you multiply coefficient of static friction and the applied force?
Oh no, the mass of B and this one.
No, no.
Normal force,
Wait, wait.
normal.
You think carefully. You think carefully. Just a moment. Those of you who just joined, okay, Aishwarya and Vanilla, we are just discussing this problem. Two blocks, one placed on top of another. We are pulling the lower block with a force of 5 Newton. Coefficient of static friction between the blocks is given. We need to calculate the acceleration of the blocks and the friction acting between them. That's the situation. Yeah, Rishi, how to calculate the friction between the blocks?
We're basically 50 Newton into 0.5. Not 51 second. Mass of block B is 3 kg, 30 into 0.5, which is 15.
Why are you
And then,
taking 30 into 0.5?
because the normal force are, 1 second, sir. 1 second, sir. I'll solve it properly and then tell you.
Okay, okay. That's why I told you, think carefully and answer. Others, if you have any ideas, you can share. How to find out the accelerations of the blocks in this case? We are applying force on one of them. We need to calculate both accelerations.
Sir, what if we only find out the like F net equals MA formula? We use it only for block B because if it is moving forward, then the same static friction will be applicable to B also, no, sir.
then that static friction will be acting on B. Then you have to consider that, no, while calculating the net force.
Yes, sir. Then we do not take like 5 kg, but we only take 3 kg. So we get like 5 by 3.
No. On 3 kg itself, 3 kg is the block B. On block B, there will be friction acting, no?
Yes, sir. So we get like we get 5 minus 15 newtons.
Where did you get 15 from?
Sir, 3 into 5, like 30 into 5, the normal force of B.
Again, why are you doing 13 to 5, Saket? 13 to 0.5. Why are you doing that?
Because we are only considering block B, sir.
Okay, I think you and Rishi, both of you, like you must be using this formula. Limiting friction is mu s multiplied with n, right? Is this what you are using?
Yes, sir.
Okay, in this formula, mu s is coefficient of static friction, n is the normal force. Which normal force are you taking? Where is the normal force 30, you tell me?
Oh, sir, the mu s is on the A block, not the ground. So I don't think we can take.
Mu s is between the block A and B. So see, you need to find out the friction between the blocks, right? I mean, you are trying to find out the friction between the blocks. Like, see, friction always acts between two surfaces that are in contact. I'm telling this to all of you. If you want to find out what friction acts, actually what you're doing is wrong, but you're trying to find out the limiting friction. I'll call it the limiting friction. If you want to find out the limiting friction between two surfaces in contact, you need to know the normal force there, not somewhere else. Okay. So one of you tell me what is the normal, or how much is the normal force between A and B?
20 newtons.
What is the normal force there doing? Or why should there be a normal force between A and B, Saket?
Sir, because both of them are in contact with each other.
In contact, okay. Are they pushing each other or pressing each other? Then only normal force will arise.
Yes, sir. A is pressing on B. B is
Due to
its weight.
Weight, correct. Okay. So A's weight will be acting downwards, but there is a block B below it, which will not allow it to fall down. So see, it's very important to visualize the forces acting on objects, as I said. So if you consider A separately, how much is A's weight? Mass is 2 kg, so 20 Newton. That is balanced by the normal force acting on it. And who exerts the normal force on A? Who or what exerts this normal force on A?
Block B, sir.
B. Okay, so it's between A and B. You can call it NAB if you want. And that balances the weight of A. So it should be 20 Newton. Now, one of you tell me the forces acting on block B. What all forces will act? Vanilla, what forces act on B?
Weight, normal.
How much is its
normal,
weight?
sir.
Correct. How much is B's weight?
3 kg, sir.
As mass.
30 newtons.
Okay. And two normal forces will be acting because it has two surfaces of contact. Correct. One normal force from A will be pressing B in the downward direction. You all know that. That force will act downwards. Okay, again, this is between A and B. The green vector that I have shown on A and the green vector that I have written on B, they are an action-reaction pair. This will also be 20 Newton itself. You can't change it. Action, reaction, equal and opposite. Okay. And the floor, the smooth surface is supporting B. So there will be another normal force acting on B in the upward direction. That is from the ground. Rishi, how much will that be?
Sir, it'll be 50 newtons, sir.
Normal force between block B and the ground. Yeah, that will be 50 newtons. It's balancing the weight of both the blocks, you can say. Or it has to keep B in equilibrium. That way also you can say, either way it will be 50 Newton. These are the forces acting on the blocks, apart from friction and that applied force. Vertical forces are these. Okay, now you all think and answer. How to find out what happens to the blocks? Any ideas? Now I told you one thing. See, keep this in mind and you always have to think about this first. If there are rough surfaces in a problem, what is the first thing I asked you to do? What should you first imagine? Write this, all of you. I will also write. If there are rough surfaces, first imagine what would happen had the surfaces been smooth. Okay, in this situation, we kind of did it in the last class. We actually did it in the last class, but one of you tell me, had the surface between A and B been perfectly smooth, what would have happened?
Sir, when B block moves towards the right, A will fall down.
B will slide to the right. Up to some time, A will stay there itself. After that, it will fall down. Okay. So had the surface been smooth, this is what would have happened. Now tell me, why did I ask you to imagine this? What is the purpose of imagining this? What will this help us with? It will help you visualize the sliding. Okay. B, like wherever A and B are A and B are in contact, B is sliding forward and relatively A is sliding backward. So it helps us visualize the sliding. Why visualize sliding? It helps us tell the direction of friction. Tell me, in which direction should friction act on the block B? If this is what would happen, and friction hates sliding, I told you, no? So how should friction act on block B? Like in which direction should it act?
Towards the
Sir,
left.
Towards the left, backwards. What exerts this friction on B? From where does it arise? What exerts friction on B? Friction is always between two surfaces, okay? One surface exerts on the other surface. So who can exert friction on B?
A, sir, because
A.
the ground is
Right. The base of A will be exerting. And as a reaction to that, B will exert friction on A in the forward direction. Okay. So if you imagine the surface to be smooth, you can understand in which direction they are going to slide relatively, and you can tell the direction of friction properly. Okay, so friction will definitely have to act in this case, because in the absence of friction, sliding is going to happen, and friction, if it is present, it will try to prevent sliding. Okay. Now, some of you tried to calculate the amount of friction. Tell me how much friction acts between the blocks. We know how much is the normal force between them. So tell me how much friction acts between the blocks. Or if you are not able to tell me why you are not able to tell, or why it cannot be calculated directly.
Sir, you mean the friction acting between A and B, right?
Yes.
1 Newton, sir.
Vanilla, how could you say it is 1 Newton?
It's 0.5 into 20.
0.5 into 20. 20 లో సగం 1.
10,
What is
sir.
okay? So you are multiplying 0.5 into 20. You are doing mu s into n. But Vanilla, you only tell me. Mu s into n is the formula for what?
Limiting friction.
What does limiting friction mean? Anyone? What is the meaning of limiting friction?
Maximum value of friction.
Maximum value of static friction, okay, is limiting friction. Now, limiting a word, that word itself should suggest that it's the limit of friction. And see, keep the basics in mind. Friction is a self-adjusting force. How much ever is necessary, only that much will act. Now you found out the limiting value and you are saying that much will act. Who told you? Maybe lesser amount of friction is sufficient. Okay. Now, according to you all, okay, Aishwarya didn't give any answer, but the other three, you think friction should be this much. Then this should be 10 Newton. Let us assume friction is 10 Newton and visualize what happens. Okay, you only tell me, one of you all. If 10 Newton friction acts between the blocks, as you all think, okay, under the influence of these forces, these are the horizontal forces. Vertical we have already seen. Okay, vertical have, I mean, they only help us in calculating the friction. They don't help in movement of the blocks. But if these are the forces acting on them, you just observe the forces and tell me, how should block A move?
Sir, that means block A's force is more than whatever block B is experiencing, right?
Forget about forces. I mean, it could be more. Doesn't matter. But tell me, under the influence of the 10 Newton force, what is going to happen to block A?
It will move towards the right, sir.
It will move towards the right with an acceleration of 10 by its mass was 2 kg. Acceleration of A will be 5 meter per second square towards right. Vanilla, you only tell me, under the influence of this 10 Newton and this 5 Newton, what would happen to block B?
It will move towards the right, left, sir.
It will move to the left with an acceleration of net force is 10 minus 5 divided by its mass is 3 meter per second square. Now go back to the original situation. You applied force on the lower block towards right. And if that much friction acts, you see the upper block going forward, lower block going backward. Does that make sense? Does it happen? Does it ever happen like that? You are pulling the lower block. Do you see it going in the opposite direction and upper block coming forward?
No, sir.
Others?
No, sir.
Can something like this happen? No. Okay. Why you arrived at this wrong answer is because you assumed friction to be 10 newtons. 10 Newton is the maximum amount of friction. But see, there is something you can get out of this also. You assume 10 Newton, you assume maximum friction to be acting. You will know whether that much friction is needed or not. Now, in this case, if 10 Newton friction acts, okay, we visualized both cases. If no friction acted, B goes forward, A stays there itself. Sliding will happen. But if all friction acted, if maximum friction acted, B goes back and A goes forward. It's the exact reverse. Are you all getting me or not? In the absence of friction, B was going forward and relatively A was going backward. If maximum friction acts, A is going forward and B is going backward. Are these two exact opposite cases or not? The case where friction is absent and the case where maximum friction is acting, are these two opposite to each other or not?
Yes, sir, they are.
Yes. But in one case, B was sliding forward, A was sliding backward. In the other extreme, A is sliding forward, B is sliding backward, which is meaningless. We know that. Somewhere between these two, there must be a case where they don't slide over each other. Okay. So in case of zero friction, B slides forward, relatively A slides backward. Actually A stays there itself, but relatively it slides backward relative to B. That is in case of zero friction. In case of friction 10 Newton, this is what would happen. B goes back, A goes forward, which is of course meaningless. So for some value of friction between 0 and 10, okay, I don't mean exactly 5, but for some value of friction between 0 and 10, there must be a case where there is no relative sliding, because for 0 we got one case of sliding, for 10 we got exact opposite case of sliding. Then for some value of friction there will be a case of no sliding. Are you all convinced with this or not?
Sir, can you explain one?
Rishi, you only tell me, when there is no friction between the blocks, what is happening?
Sir, they'll just like the B will move and the A will fall off.
B will move forward, A stays there, right?
Yeah, yes, sir.
That means relatively, like you look at the surface of contact between A and B, relatively B goes forward and A goes backward. That is how sliding happens, right?
Yes, sir.
When does this happen?
When like both of them there's no friction.
When friction is 0, this is what would happen. Okay, these arrows are representing relative motion, not actual motion. Okay, because actually A doesn't move. Let it be. Now, when you imagine maximum friction or full amount of friction to be acting, which is 10 Newton, now Rishi, you tell me what would happen.
Sir, so both of them will.
Which way? Direction?
Towards the right.
B is
no, left. Yeah, left, sir.
B moves to the left. A moves to the right.
Yes, sir, yes.
When would this happen? Like how much friction is needed for this to happen?
10 Newton.
10 Newton. Okay. So for 0 Newton friction, the relative sliding was like this. A backward, B forward. And for 10 Newton friction, situation is like this. A forward, B backward. In both cases, there is sliding and there is exact opposite sliding. So what I'm saying is somewhere between 0 Newton and 10 Newton, for some value of F, let's say F0, there should be a case of no sliding at all. Because in one case we have forward sliding, in another case we have backward sliding. Then somewhere in between there should be a case of no sliding, no?
Yes, sir, yes.
Others also, did you all get the point or not?
Sir, should block A and B move with the same acceleration?
See, I mean, are you asking me for the answer or is you are saying it should always be like that? అంటే ఈ కేస్కి ఆన్సర్ అడుగుతున్నావా లేకపోతే ఎప్పుడు రెండు ఒకేలాగా మూవ్ అవ్వాలని అడుగుతున్నావా?
అంటే నార్మల్గా ఒకే యాక్సిలరేషన్ తో మూవ్ అవ్వాలా లేదా?
The other day we visualized, no, phone on the book. If you pull the lower object gently, they'll slide together. But if you pull the lower object with lot of force, they will not be able to slide together. Okay, so now we have to find out what exactly will happen. We have to find out whether 5 Newton now is a gentle force or too much of a force for these blocks. Okay, so see, you all assumed maximum friction to be acting, and in that case you see something weird happening which does not happen in a real situation. What that suggests is that friction will not be 10 Newton. That much friction is not needed. Okay, because if you imagine that much friction to be acting, it is leading to a meaningless situation. Okay, so it means that much friction will not act. That much friction is not needed. For a lesser amount of friction itself, sliding between the blocks can be prevented. Okay, that is what all this suggests.
So 2 Newton friction.
To them, I'm not asking the answer, but visualization and all is important first. We'll come to the answer. Don't worry. Okay. Now, how many of you think friction acting will be 5 newtons? Limiting friction is 10, okay. We found that limiting friction need not act, that much is not necessary. But lower block is being pulled with 5 Newton force, no? Should friction acting be 5 newtons? That is my question. If yes, how do you justify? If no also, how do you justify? Vanilla, you said friction should be 2 Newton. Why should it not be 5 Newton? And if it is 5 Newton, what happens?
Sir, if friction is 5 Newton, the B block will not move.
If friction is 5 Newton, B block will not move and
A block will move towards
A
the
block will move forward, which is again meaningless. You are pulling the lower block. Why will the upper block start sliding forward on its own? That is meaningless. So friction will not be 5 Newton in this case. Okay. As I said, friction does not have to oppose any force. What friction does is oppose sliding. And for that, how much is necessary? That much only will act. Okay. So 5 Newton also is leading to a meaningless situation. So friction acting will not be 5 Newton. Okay. Now, based on all these observations, we can tell one thing. For zero friction, there was one kind of sliding. For maximum friction, there is sliding in opposite direction. So friction need not increase up to the maximum extent. That we can tell for sure. And if friction is not increasing up to the maximum extent, that means the friction acting is static only in nature. Static friction will act in this case, and it will successfully make the blocks go together. It can prevent sliding. That also we can conclude, because with 10 Newton friction, which is the full amount of friction available here, with 10 Newton friction, we are seeing sliding happening in the opposite direction. So with a friction of less than 10 Newton itself, sliding can be prevented. So sliding can be prevented means static friction will act. So what happens? Finally, we can conclude that what is going to happen is something like this. There will be some friction acting on B, there will be some friction acting on A. And these two blocks are going to slide together. That much we can tell for sure now. Okay. For some amount of friction, which is less than 10 newtons itself, these two blocks will slide together, let's say with a common acceleration of A. Vanilla, how did you say it is 2 newtons?
Sir, for both the blocks to move with the same acceleration, the friction should be 2 Newton.
Okay. Like you wrote Newton's second law equation and solved.
Yes, sir.
Okay. So did you all understand that this is what is going to happen? The blocks are going to move together. Saket.
Yes, sir.
Okay. Rishi, tell me, how did we conclude that the blocks are going to move together?
Sir, because when the friction was zero, it wasn't both of them would only B would move and A would just fall off. Like
yeah, some kind of sliding would happen when friction is zero.
And the 10 Newton one doesn't, like, it's too much for it's too much force.
Zero friction. Correct. Yeah. Continue.
So something in between should make both of them move front. So
together.
We figured that out. And
okay. So finally, what is going to happen is this: they are going to slide together. Okay. Now write equation. We found out what is going to happen. Actually, no. To solve such questions, you can start with this assumption. Why I explained this way is because some of you thought friction will be 10 Newton. So I started explaining that way. If 10 Newton acts, what happens? We visualized, but usually we don't visualize that. Usually what we do is we assume the blocks move together. Why? Because we are giving the benefit to friction. Okay, benefit of doubt to friction, you can say, or advantage to friction, whatever you call it. Friction tries its best to prevent sliding, no? So we'll assume sliding is prevented successfully and the blocks don't slide over each other. We'll start with that assumption and we'll find out how much friction is necessary to achieve that. Then we will check with the limiting friction. Is that much friction available or not? If it is available, then yes, that is what will happen. Okay. So here we know, we have concluded for sure that they are going to accelerate together. But let's say this is an assumption now. Let us assume they accelerate together. In that case, Aishwarya, tell me how to write Newton's second law. Newton's second law is F net is equal to ma. How to write that for the first block, for block A? No response. Okay, Saket, you tell.
Sir, F net will be 0.
Friction is acting on it. Why will net force be 0? I told you they are going to accelerate together.
Yes, sir. For block, only for block A, sir.
Only for block A. Yes. Tell the equation for block A.
Yes, sir. For block A, it is going to be. Sir, the normal force will be 50 or only.
Its weight and its normal force are balanced anyway. A is going to slide horizontally, no? Then look at the horizontal forces.
Okay, sir. So it is going to be 20. Will the normal force be 20, sir?
Normal force on A is 20, that we have already calculated.
No, sir, like if you're calculating friction for only block A, will we take
Arey,
normal?
who asked you to calculate friction? You can't calculate friction directly. Again, you are again doing mu s into n. Mu s into n is the limiting friction, maximum amount of friction. We have found that maximum amount of friction need not act in this case. So now we are calculating friction the other way. From acceleration, we'll find out friction now. We won't use mu n. Saket, did you understand?
Sir, I'm confused, sir.
Okay, tell me. Did you understand that these blocks are going to... Okay, not even understand. We are assuming these blocks slide together, okay?
Yes, sir.
What can make block A slide forward?
Block
What means
A,
which force? Which force can make block A slide forward?
friction, sir.
Friction is the only force, no?
Yes, sir.
So I'm asking you how to write Newton's second law equation for the block A for its forward motion. I'm not asking you to solve and tell me the answer. Just tell me the equation.
Oh, sir. 2A, sir.
What is 2A?
2A is F.
No. See, Newton's second law has to be in this form. F net equal to ma. Okay, left hand side or right hand side unta equation ki. Tell me the complete equation.
F is unit equal to 2A, sir.
On A, the net force is friction itself. So you are going to write F is equal to 2 small a, where small a is the acceleration with which the blocks slide. Okay, Saket, tell me Newton's second law equation for the block B. Block B is also sliding forward only with the same acceleration A. Based on that, tell me the equation.
5 minus F is equal to 3A.
Good. 5 minus F is equal to 3A. Now there are two unknowns, friction and acceleration. Two equations are sufficient. Solve these two equations. If you add them, left hand side becomes 5 is equal to 5A. You get an acceleration of 1 meter per second square. And if A is equal to 1, you substitute in any one of the equations, you get friction as 2 newtons. Now you all tell me, how much was the limiting friction between the blocks? Like, what is the maximum available friction between them?
10 newtons.
10 newtons. Mu s into n was 10 newtons. How much is needed to make them go together? We assumed the blocks to be sliding together, and for that we see that the friction required is only 2 newtons, and this is comfortably less than the limiting friction. So this is what is going to happen. Our assumption is correct. Okay, we'll assume blocks moved. We'll assume surfaces don't slide over each other. For that, we found out how much friction is required. And then we compared it with how much friction is available. And we see that the required amount of friction is less than the maximum available amount. So our assumption is correct. They will move without sliding over each other. Okay, so directly when you're asked such a question, you can assume they move together and find out the friction and compare with limiting friction. But since some of you thought limiting friction will be acting, maximum friction will be acting, I showed you what happens if maximum friction acts, and we see that it leads to something meaningless. So that is also a way to conclude that maximum friction need not act. A lesser amount of friction will do the job of preventing sliding. And since sliding is prevented, you can be sure that they move with common acceleration. Write two equations, you will get the friction acting. Is this clear to all of you? Any doubts in this?
Sir, so let's say in a question, we assume that both of them will slide together and we make the equation. But the limiting friction is lesser than what we got the friction.
Suppose in one question you found that the friction needed to make the blocks move together is some 15 newtons, but the limiting friction is only 10 newtons. What does that suggest?
So no, I'm saying when like the force needed is higher than the limiting friction.
That's what. Let's say force needed is 15 newtons, but limiting friction is only 10 newtons. So what can we say based on that? Of course, that is your question. I'm asking the others.
That they won't like slide together. Is that what happens?
Yes. How you arrived at that 15 Newton force friction is by assuming that they slide together. And for them to slide together, you are finding friction needed is 15 Newton, but available is only 10. That means sliding together won't happen. They'll slide independently. Means they'll slide separately. B will slide faster, A will slide slower, and relative sliding is there. So in that case, we'll have to apply kinetic friction. We'll solve questions like that also. Today's class is completely based on this. Okay, is this situation clear to all of you?
Yes, sir.
Okay. Now see, we pulled the lower block with 5 Newton force and somehow friction adjusted itself, and friction of 2 Newton is sufficient to make them move together. Now one of you tell me, what will happen if you slowly increase this force? Suppose you start pulling it with, let's say 6 Newton, 7 Newton. Will the block still be able to slide together up to a certain extent?
So like last class we did like when we pull it too fast.
So when we slide the book too fast, what happened?
The A will not move, it'll just like fall off and it'll remain in the same, it'll slide back and this will go forward.
Relatively it will slide back, but see, that is when you apply too much force. I'm just talking about 6 Newton. How do you know if 6 Newton is too much or not? So my question is, if we gradually increase the pulling force, what is going to happen?
At one point only the B block moves.
At one point, mean till then?
So this will move, it'll move further, but the more force you put, the lesser A will move.
Okay, don't say the lesser A will move. That is not correct. A will move. B will move more than A. That's all.
Yeah, that's what I meant.
Okay, others, what do you think? If we gradually increase this force from 5 Newton, what will happen to friction? What will happen to the blocks?
So the friction between the blocks will
increase. See, now when we are pulling with 5 Newton force, 2 Newton friction is sufficient to make them go together. But you pull harder, okay, you increase the force with which you are pulling, then the system will tend to move with a greater acceleration, no? Then the friction needed will increase, the demand on friction will increase, and friction can increase itself up to 10. Okay, so you can afford to increase the 5 Newton force more if you want to higher values till the friction becomes 10 Newtons. The blocks will slide together only. When the pulling force becomes too much, means when the demand on friction becomes more than 10, that is when friction gives up. Then sliding will start. Okay, so now the next question will be like based on the same situation. The next question is to find out with what maximum force you can pull the lower block such that the blocks slide together on the ground. Okay, think about this carefully, all of you. Once again, mass of A is 2 kg, mass of B is 3 kg, just to remind you. Can any of you tell me how you are trying to solve this?
So we can consider the tension, the friction between block A and B as 10, and we can
See,
find also.
correct. See, we are looking for the maximum force with which we can pull the lower block such that they slide together. Now, what limits this force is the friction, right? Because friction has limits, the pulling force will have limits. Otherwise, if you want, you can pull it with whatever force you want. But to make them move together, you have to consider friction, and friction has limits. So, as we increase the applied force, F, capital F, friction starts increasing. The demand on friction will be more to keep them moving together. But what is the limit of friction? We know friction can only increase up to 10 newtons in this case. So we'll assume all that friction is acting. With that, you calculate the acceleration, and with that you calculate the force, or you write Newton's second law on both the blocks, you'll get the answer. Do this quickly, all of you. Did you understand the idea? If you have any doubt, you can ask. Otherwise, solve it.
But it's the same approach as the last one.
Not exactly. Last question was in the last question, capital F was known. Small f and a were to be calculated. Now, small f is known, capital F and a are to be calculated. I mean, equations are the same. ఏం పవన్ లేట్ అయింది ఈరోజు?
సార్ మమ్మీ లింక్ షేర్ చేయలేదు సార్, ఆఫీస్ వర్క్లో మర్చిపోయాను.
ఓకే నో ప్రాబ్లం. రికార్డింగ్ పంపిస్తాలే తర్వాత.
ఓకే సార్.
Make it fast, all of you. Apply Newton's second law on both the blocks. Okay. Saket, tell me, how will you write Newton's second law for the block A?
Sir, 10 is going to be equal to 2a, sir.
10 is equal to 2a. So how much is A from that?
A is 5
Meters
meter
per second
second.
square. How will you write the same equation for block B?
Sir, F max plus 10 is equal to 3a.
Why are you adding 10? Which
Sorry,
way is
subtract. Sorry. Minus
friction is
10
acting in the backward
is
direction?
equal to
Is equal
3a,
to
sir.
mass into acceleration. We know A is 5, so 3a would become 15. Send 10 that side. So the maximum force with which you can pull the lower block is 10 plus 15, 25 newtons. Is this clear to all of you? If you have any questions, you can ask. Okay, so the first question was, if we pull it with 5 newtons, what happens? We found that with 5 newton, it is possible that they slide together. And we found out that 2 newton friction is sufficient. Even though the limiting friction is 10 newton, 2 newton is sufficient, that much only will act. Next question was, what happens if you keep on increasing that 5 newton? Up to what maximum extent can you increase such that they still slide together? And we find that it can be increased up to 25 newtons, in which case the friction acting will be 10 newtons and the common acceleration with which they slide is 5 meters per second square. We can make them accelerate at that rate, maximum, not more than that. Okay, now the obvious next question that follows is what happens if we apply more than 25 newtons? Like now we kind of know. Like what is going to happen, we know. We don't have to do any comparison, or we don't have to start from the scratch. It's the same situation. So let's say we apply a force of, how much shall we take? 40 newtons. First tell me what is going to happen. I don't want any numbers. I don't want exact values, but how will the blocks move?
Since it's like much, we will just
Rishi, your voice is
because
breaking.
so can you hear me now?
Repeat.
Sir, the same thing, sir. When you pull it too fast,
Hmm.
straight, because you're putting too much force, then the maximum force is 25 Newton. So A will just stay there, right?
Why will A stay there? Will no force act on A?
I mean, it will, but like,
If it acts, then how can A stay there itself? If there is a net force acting on A, how can you say it stays there itself?
That B will move faster than.
Both will move forward. You will see B moving faster than A. So situation will be like this. I'll have to show you both of them moving. So A moves forward. Only thing that happens is B moves forward more than A. So they'll have their own accelerations this time. What makes A move? Friction. The moment we start applying that 40 Newton force, friction acts like this. But now, even if limiting friction 10 Newton acts, it won't be enough to prevent sliding between them. It can't keep them going together. Okay, you can check if you want. Assume friction is 10 Newtons. 10 Newtons. Block A's mass is 2 kg. 10 Newton friction and 2 kg mass. A goes with an acceleration of 5 meters per second square only. Okay. Now come to B. There's a 40 Newton force acting and friction is only 10 Newton. 40 minus 10 is 30. B's mass is 3 kg. Then B goes with an acceleration of 30 by 3, 10 meter per second square. Okay, even if maximum friction acts, they can't go together. Okay, and if they can't go together, the friction acting won't be static anymore. If two surfaces slide over each other, what kind of friction acts between them? Anyone, if sliding is happening, what is the kind of friction acting between surfaces?
Kinetic friction.
Kinetic friction. What is the formula for kinetic friction? Kinetic friction acts between the blocks. The formula for kinetic friction is mu k multiplied with n. Kinetic friction has no choice. It can't be self-adjusting and all. Because sliding has already started, it has to put its maximum effort. So kinetic friction will be this much. Static friction can be less than the limiting value if necessary, but kinetic has no choice. Okay. Now I didn't give you mu k value. Let's say mu k is 0.4 in this question. Okay. Take mu k, kinetic friction coefficient, as 0.4. Normal force between the blocks is 20. So that will give you a kinetic friction of 8 newtons. So now what will happen? 8 Newton friction will act on A in the forward direction. 8 Newton friction will act on B in the backward direction. As a result, 8 is the only force acting on A. So for block A, net force is equal to mass into acceleration. So block A goes with an acceleration of 4 meters per second square. And for block B, 40 minus 8, that is 32, is equal to mass into acceleration. So block B goes with an acceleration of 32 by 3 meters per second square. That is more than 10 meters per second square. So they accelerate at different rates. And eventually, when B moves forward too much, A will fall off. Is this clear to all of you? This time, even maximum static friction can't keep the blocks moving together. It cannot prevent sliding. So since sliding cannot be prevented, sliding happens and kinetic friction comes into play. So we applied the formula for kinetic friction, found out how much will act. And and based on that, we are finding out the accelerations of the blocks. Did you all understand? Okay, see, but what I want you to learn from all this is how to approach questions based on friction. Okay, what was the first point I told? If there are rough surfaces in a problem, what should you do? I made you write the statement also. I don't know how many of you wrote, but what should you do if there are rough surfaces in a problem?
Sir, imagine what would happen if the surface was.
First, imagine the situation with smooth surfaces. That will help you visualize how the blocks are going to move, objects are going to move. That in turn will help you visualize how friction must act. The direction in which friction must act, you will be able to tell. Then, these are cases where you don't know what will happen. Whether the blocks will slide together or separately, you don't know. So, what I suggest is, assume they slide together, find out how much friction is necessary to make that happen, check if that much friction is available or not. If it is available, well and good, your assumption is correct. If it is not available, if that much friction is not available to make them slide together, then your assumption that they slide together is wrong. So they slide separately, apply kinetic friction, get the accelerations. Okay. Solve another question, all of you. We'll change the numbers. Lower surface, ground is smooth itself. And the coefficient of friction between the blocks, mu s. Let's take, okay, 0.4. Mass of A is 2 kg. Mass of B, let's say, is 4 kg. A force is acting on B like this. Let's say 5 Newton itself. And this time we are applying a force on A also in the forward direction. In the backward direction. And let's say that force is, okay, 4 Newton. Find out what happens. Okay, like the question is to calculate the accelerations of the blocks. In the process, you will anyway find out whether they move together or not. Okay, suppose static friction is not sufficient, you should know the coefficient of kinetic friction also. Take that as 0.2. Solve this, all of you. I got one answer for acceleration as 1/6. And I think in that case, you assume them to be sliding together. Okay. Saket, how are you trying to solve this?
Sir, I'm actually confused, sir, because I did it in 2 ways.
Tell me one of the ideas.
Sir, first I took them both of them individually and calculated, and I got different accelerations.
Wait. How did you take them individually? How much friction did you assume?
I took kinetic friction, sir. Friction was 4 newtons.
You assumed them to be sliding separately.
Yes, sir. And then again did it by taking them as 6 kg as a whole.
Of course, you'll get different answers.
Yes, sir. So I did not understand what to use, sir.
Okay, you found out
Yes.
both cases. That's fine. Wait. But Saket, tell me, what does friction try to do? Does it try to make them slide together, or does it try to slide them separately first?
It will try to slide them separately, sir.
Friction tries to prevent sliding, no? It will try to make them go together.
Yes, sir.
Ante kada? If it is not able to do that, then sliding will happen. Then it's like friction has given up.
Yes,
So now
sir.
you tell me which of your answers is correct.
Taking them together.
If you take them together, is friction sufficient?
No, sir.
Have you checked that?
No, sir.
Check. That is what I told you in the last case also. I'm telling this to all of you. Assume they slide together. Okay. On the floor, they slide. Between each other, there is no sliding. So A and B move together. Assume like that. And find out how much friction is necessary and whether that much friction is available or not. You check. Yeah, Rishi, you were saying something?
Sir, I got confused about which mu to use where, sir.
If they are moving together, if there is no sliding between the blocks, you have to use coefficient of static friction. If you are sure they will slide over each other, then you have to use coefficient of kinetic friction. Aishwarya, any answer? Okay. Let's assume they slide together. So you'll have to think of both of them as one object. If you think of them as one object, what is the combined mass? Vanilla, you tell me, what is the combined mass?
6 kg.
2 plus 4, 6 kg, correct. What is the net force? If you take them together,
1 Newton was
1 Newton. Listen, all of you. I'm sure you all must have visualized the situation without friction. In the absence of friction, B would go to the right, A would go to the left. So friction will act like this. On B, the friction is to the left. On A, friction is to the right. But, okay, listen, all of you. If you take both of them as one system, this term is important. If you take both of them as one system, friction becomes an internal force to the system. One of you tell me, what do you understand by the term internal force of a system?
It is inside.
It is a force exerted by one part of the system on another part of the same system. Such forces are called internal forces. Now, who is exerting friction here? A is exerting on B, B is exerting on A. But if you take A and B as one system, then it's like one part of system exerting on another part of the same system. F becomes an internal force, friction. Always remember, internal forces do not disturb the overall motion of the system. What do I mean by that? You see, every force has an equal and opposite reaction, okay? The friction exerted by A on B is an internal force. The friction exerted by B on A is also internal force. They are an action-reaction pair. What is the resultant of those two frictions? 0. On A, friction shows effect separately. On B, friction shows effect separately. But A and B together, if you take, friction becomes an internal force. You don't have to consider it for the net force. Okay. So remember this point, all of you. Internal forces. In fact, in the next class, this is going to be more important. Next, we'll discuss conservation of linear momentum. Internal forces do not contribute to the net force on a system. Okay, now we are taking both blocks as one system, so you don't have to consider friction at all. It will be acting, but the overall motion will not be disturbed by it. So net force becomes 5 minus 4, that is 1 Newton. Okay, in that case, the common acceleration with which they move should be net force divided by the mass, 1/6 meters per second square. Now we have to check if this much acceleration can be provided by friction or not, or if this much acceleration can arise in the presence of friction or not. For checking that, we will have to take the block separately, because now we need to calculate the friction acting on the blocks. If you consider both of them as one system, friction won't appear in the equation at all. If you consider them as separate systems, then friction will be an external force to them. For A, friction is an external force. It is coming from B. Only for B, friction is an external force. It is coming from A. Okay. So now you will have to divide the system into separate parts on which friction is an external force. So let's consider block A. If they slide together, we know they should slide with an acceleration 1/6 meters per second square this way. Then on A, there are two forces acting. One force is friction, the other force is 4 Newton. So the equation you write will be friction was acting to the right. So friction minus 4 Newton should be mass of A into acceleration of A. That becomes 2/6, 1/3. So the friction required to make A go with that much acceleration is 4 plus 1/3. That is 13/3 Newtons. 13/3 is 4 point something, 4.33 Newtons. This much friction is needed to give that common acceleration of 1/6. Saket, is that much friction available or not? How much is the limiting friction in this case?
4, sir.
How will it be 4?
Sir, I took kinetic friction.
Why will it take kinetic friction? Limiting friction is the limit of static friction.
Eight newtons.
It will be 8. The normal force. Okay, Vanilla gave answer long back, so she must have been getting bored listening to all this. Anyway, the normal force between the blocks is 20 Newtons. Okay, the weight of A has to be supported. 20 Newton is the normal force. Coefficient of static friction is 0.4. So limiting friction here is 0.4 into 28 Newtons. But how much is needed to make them go together? 4.33, which is available. So our assumption is correct. They will move together with this common acceleration and this much friction acting between them, 4.33 Newtons. Okay. Fine, we'll stop it here for today. So all we discussed today was cases where one block is placed on top of another, but basically what we discussed is how to approach questions with friction. Imagine the situation in the absence of friction and assign directions for friction. Then you just need to check if friction is sufficient to prevent sliding or not. So you can assume there is no sliding, find out how much friction is necessary, check with limiting friction, whether that much friction is available or not. If it is available, then your assumption is correct. If it's not available, then you will have to apply kinetic friction and find out individual acceleration separately. Such questions also we have done. Okay. So, right, I'll send you a worksheet based on questions like that. But still, I still didn't get any answers to the last worksheet that I sent. Never mind whether you solve that or not. This friction worksheet you will have to solve. And Monday's class, we will start discussing conservation of linear momentum. Very, very important concept. And as I said, in fact, all that we discuss in this chapter is important. We'll be using these ideas in almost every chapter that follows. Okay, so don't miss any of these classes. Fine, thank you all. We'll continue on Monday.
Thank you, sir.
Thank you, sir.